Alright, so this is P.8, which is solving inequalities, and things are going to start showing up here. So here's a key term. It's called an extraneous solution. An extraneous solution is simply a solution you arrive at algebraically that does not work in the real world. It's kind of a nonsense solution. Now, the real world would always be represented by a graph. Okay, so I'm going to start off with a solve by graphing. We're supposed to solve by graphing 2x minus 3 greater than or equal to negative 4x plus 1. So again, we think of this as two separate equations. We think of y equals 2x minus 3 and y equals negative 4x plus 1. And, you know, this is an Algebra 2 course. We're doing our prereqs. You should understand y equals mx plus b. Doesn't mean you do, it means you should. So y equals mx plus b, m is the slope, and b is the y-intercept. Now, we are dealing with inequalities too. So this is a 2x minus 3 greater than or equal to negative 4x plus 1 situation. Now, we will not see an extraneous solution show up on this one, but it might show up on one of the other ones. So let's graph here. We cross the y-axis at negative 3. We have a slope of 2, rise 2, run 1. And since I'm actually solving here, I'm going to have lots of points. So that'll be that line, and we'll make it red. I'll try to keep it different colors for you. And the other one is negative 4x plus 1. It crosses at positive 1, and it falls 4 and runs 1. And it falls 4 and runs 1. It looks a little something like this. All right, and it ain't perfect. It's a graph. It's not going to be perfect. Okay, now, I need to understand the context of what this is asking. That's a big deal for a lot of kids. That is a greater than or equal to symbol. So it is asking, where is the line 2x minus 3 above or intersecting, because we have equality, the line negative 4x plus 1? Where is it above or intersecting? And this is a hard thing for kids to realize, I've noticed over the years. It's happening from here to here. That is where 2x minus 3 is above or intersecting. And, you know, one of the issues with graphing is getting a point. Okay, so like, what is this x value? I think it's about 7/10. It might be something else. I think it's about 7/10. I haven't done this problem yet, so I don't know what the answer is. I think it's about 7/10. So, and I'm moving right for this shading, so I'm going to be greater than or equal to 7/10. Interval notation would be, I do have equality here, even though I'm using a rounded answer. I'd use a bracket from 7/10 to infinity because I'm moving to the right. Set builder would be all values of x such that x is greater than or equal to 7/10. Now I want you to realize here, the weakness in graphing is that I'm getting an approximation. The strength in graphing is that I can see the solution, okay? That's the strength in graphing, that I can see. Now, when you do your first initial inequalities, seeing isn't a big deal. Like the next one, it's not required. Now solve it algebraically, okay, algebraically. It's as simple as your x's on the one side and your numbers on the other. So I'm going to move my x's left and my numbers right. So I've already got a 2x on the left. I'm shifting the 4x over. That makes it positive. Greater than or equal to sign. I've got a 1 on the right, and I'm shifting the 3 over, making it positive. If I add 2x and 4x together, I get 6x, and the 1 and 3 together makes 4. If I divide out the 6, I get 4/6, which reduces down to 2/3. And I forgot my inequality symbol. X is greater than or equal to 2/3. Now you should know that 2/3 is, you know, it's exactly 0.666 with a bar over it, right? So I thought it was about 7/10, and it was pretty close. But algebra will give you a level of exactness that a freehand graph will not, plain and simple. So both things are suggesting that that is the correct answer. So anyways, the true interval here would be from 2/3 on to infinity, because I am greater than or equal to 2/3. Or all values of x such that x is greater than or equal to 2/3. Now, it's worth talking about this in Algebra 1 and in your younger years, what they would have you do is they would have you visualize these things on a number line. And you would have put a solid dot at 2/3, and you would have thought, okay, I need to shade right. Maybe you remember that, maybe you don't. So a number line is suggesting that you're that 2/3 there all the way to infinity. That's what the number line is suggesting. In Algebra 2, though, it's better if we look at the actual graph, sometimes. Moving forward, solve this one both graphically and algebraically. I hadn't done this one, so I have no idea what it looks like. Not a clue. What is it asking? Okay, first off, let's talk about what it's asking. I want you to pay attention. That is a less than sign. Okay, that is a less than sign. So let's talk about what it's asking. It's asking where is the graph 1/2 the absolute value of x minus 2 plus 1 below, it's a less than sign, the line 2x minus 5. Now remember, 1/2 absolute value of x minus 2 plus 1 is a v. 2x minus 5 is a line. But where is it below? This thing's already in the proper form. It's in the a times x minus h plus k form. We're going to have a vertex at 2, 1. Our slope here, 1/2, or rise 1, run 2. It's linear. You can do rise 1, run 2. And our graph is going to look something like this for the left-hand side. On the right-hand side, that's, again, mx plus b. Quit being that kid who doesn't understand mx plus b. We've got to fall 5, rise 2, and run 1. Now, graphically, we're talking about the v being below the line. That happens here, okay? Graphically, I can tell you that I think x is a little more than 3. So x is just a little more than 3. But am I that accurate? Probably not. Now, the issue with algebraically is this is an absolute value equation. And if it's an absolute value equation, guess how many answers it's going to provide? It's going to provide 2. And you're going to have to throw one of them away. That's why the big picture comes into mind, okay? So let's do the algebra. The first step in solving an absolute value equation is to isolate absolute value. So I'm going to subtract the 1, okay? That's going to give me 1/2 the absolute value of x minus 2 is less than 2x minus 6. Now, the opposite of dividing by 2 is to multiply by 2. And if I multiply the left-hand side by 2, I had better be sure that I multiply everything in the right-hand side by 2. So now I have the absolute value of x minus 2 is less than 4x minus 12. Now, I have performed the isolation step. I get to write 2 equations. The first equation is as is without the bars. I'm going to keep the inequality symbol. The second equation, I change the sign on the stuff inside. So it's negative x plus 2 less than, still 4x minus 12. My little less than symbol looks like a C, doesn't it? All right, again, if I'm going too fast, slow the speed down. It's 2:54 and I want to go home. Let's get my x's on the left and my numbers on the right. X minus 4x would be on the left, and the right-hand side would be negative 12 plus 2. X minus 4x is a negative 3x. So negative 3x less than negative 10. Divide by the negative 3, and I get positive 10/3, which, by the way, if I think about the old mixed number concept, which I'm not a huge fan of, but you need to understand that that's 3 1/3, which is about what I thought it was. So it turns out this is a good actual solution, right? The other one is probably crap. It is what we call extraneous. And I'm going to do a little different. I'm going to shift my x's right and my numbers left. That way I can keep the x's positive. So 4x plus an x would have a 5x on the right-hand side, and the left-hand side would be 2 plus 12, which is 14. And I divide by 5, and I get that x is greater than 14/5. 14/5 would be 2 4/5, or 2.8. Now, there's no justification of that answer, okay? This one wins. This is the answer. This guy right here would be the extraneous dude. That's the extraneous guy. So that's the one I want. Now, I do want you to write your answer in interval notation and set builder notation, and the graph supports this whole moving right. So if I like my set builder notation, all values of x such that x is greater than, and it is a greater than sign, 10/3. If I like my interval notation, it'd be 10/3 all the way to infinity. Pick your poison, okay? Red pill, blue pill, pick it. All right, solve this one graphically and algebraically. So graphically, we just graph this side. We're going to go left 3, down 4. Our slope is 2, rise 2, run 1. And we'll just see what we get. You know, graphing is a skill that kids just don't want to accept that they need. And the truth is, you need it to get through an algebra class. X plus 1 is going to cross the y-axis at 1, and then it's going to rise 1 and run 1, or vice versa. It's going to fall 1 and run back 1. Now, what is the question asking? It's asking, where is the v above the line? Hopefully you see that. That's the question. Where is the v, because absolute value, above the line? Now the v is above the line here and here. And I don't know the exact coordinates of that intersection. It looks like it might be, it's like -3.5. This one's a giver. That's a 1, right? Have a greater than symbol. So let's see what the algebra says. We're going to isolate absolute value. Let me write down the equation. I'm going to add 4 to both sides. Let's do the easy stuff first. That's how I teach. Easy first. Always do the easy stuff first. So if I add 4, I think I'd get 5, right? Now, while the opposite of multiplication is division, you would be creating fractions, which may or may not be a big deal. You know, I don't even want to show it. I'm just going to go ahead and divide by 2. All right, so now I have the absolute value of x plus 3 is greater than 1/2 x plus 5/2. And I can write my two equations. One of my equations would be x plus 3 greater than 1/2 x plus 5/2. Or, and hear me out, kids, negative x minus 3 is greater than 1/2 x plus 5/2. They both have basically the same maneuver here. I'm going to have to subtract 3, so I need to be thinking about what 5/2 minus 3 is. That's 5/2 minus 6/2, which is negative 1/2. On the other side, I'm doing a single x minus 1/2 of x. Got a fraction, sorry. But that's going to give me 1/2 x on the left, and on the right-hand side, I have negative 1/2 as well. Cool. I'm going to divide out the half on both sides. A half divided by a half is, no surprise, 1. Negative because you had a negative or positive. So I have a solution at 1, negative 1, which I already knew about, right? And I'm going to get the real answer here. I'm not going to have an approximation. And this one's going to take a couple more steps. It really is. I actually feel like moving this over, because that's going to make that a 1/2 x plus an x, which is 3/2 x. And subtracting, so I'm thinking negative 3 minus 5/2. Again, negative 3 was negative 6/2. Negative 6/2 minus 5/2 is negative 11/2. Hooah! Lots of stuff going on there. All right. Now, there's lots of ways of doing this problem. I'm just going to double everything to eliminate that fraction, because if I distribute there, it's gone. It's gone. Negative 11 greater than 3x. Divide out the 3, and I get that negative 11/3 is bigger than x. or that x is less than negative 11/3, which I believe is about where I thought my answer was. Negative 11/3 would be, negative 3 2/3. So I actually have the correct numbers here. All right, so what happens is that I'm above from negative infinity all the way to negative 3 2. I'm not right 11/3. I just can't do mixed numbers. To negative 11/3, union with this piece of the graph, which is 1 to infinity. You'll notice I didn't use brackets. That's because that inequality symbol didn't have equality. It was literally an inequality, not equal. If I like set builder, all values of x such that x is less than negative 11/3, or and, doesn't really matter, or x is bigger than 1. So it looks like that, bigger than 1. All right, last one. Solve the following inequalities, then decide if you can trust the answers. Probably is the reality of it. With absolute value, if you see absolute value, it's a maybe. All right? It's a maybe situation. These are not absolute values. So with linear, with lines, yes, every time. Absolute value is a maybe. It really is. Because absolute value might not have any solutions, but you make a mistake and you don't think, and turns out you're wrong. Anyways, let's do this linear one. First thing that occurs to me is probably the subtraction of 1. That would give me less than 2x minus 5. And I'm also thinking about the distributive property as well. 5 times x minus 3 is 15x minus 15. So 15x minus 15 is less than 2x minus 5. And now I'm kind of thinking x is on one side. I could have swore I changed my color there. And numbers on the other. So I'm going to have 15x less than 2x on the left-hand side, and negative 5 plus 15 on the right-hand side. Now 15, why did I write it the way I wrote it? 15x minus 2x on the left-hand side, and negative 5 plus 15 on the right-hand side. 15 minus 2 would be 13x. Negative 5 plus 15 is 10. Divide out the 13, and I'll be done. X is less than 10/13. And on a line, linear relationships, you can always trust it. Absolute value is kind of funny. It's not often, but sometimes you cannot trust what you wrote with absolute value. It's just not doable. Okay. Easy first. We subtract 3. Twice the absolute value of x minus 4 is less than or equal to 4x minus 8. We're going to divide out that 2. Absolute value of x minus 4 is less than or equal to 2x minus 4 because both those pieces were divisible by 2. And we're going to write our two equations. The first equation is as is, x minus 4 equals 2x minus 4, or, and hear me out, negative x plus 4 is equal to 2x minus 4. All right, I'm going to shift x's left, and I'm going to shift numbers right. Negative 4 plus 4 equals twice x minus x. Negative 4 plus 4 is 0. 2x minus x is x. There you go. You got a solution at x equals 0. On this one, I'm going to shift my x's right as well. And I'm going to shift my numbers left. So my next line that I have up here, all right, is 4 plus 4 equals 2x plus x. And 2x plus x is 3x, and 4 plus 4 is 8. And for some reason or another, I dropped my inequality symbols. Those were less than equal. Divide by 3, and I get that x is greater than or equal to 8/3. Now, the real question is are these things right? Like I have an answer that says x is greater than or equal to 0, or x is greater than or equal to 8/3. Those are my two answers. Are they right? Now, probably. Let's just see. So, I don't feel like graphing these by hands. I'm going to go to a site called Desmos. You should have been there by now in your academic career. If you haven't, I just don't know what's going on. The original inequality was, left-hand side was two absolute values of x minus 4 plus a 3. That was the left-hand side. Right-hand side was 4x minus 5. And the deal here, again, was where is the where is the v below the line? Where is the v below the line? And the v is below the line only there. Once x hits about 2 2/3, which is hopefully an answer I have. Let's see. Yeah, I do. It's right there. Did we get the same answer both times? No, we got a 0 too. The 0 doesn't make any sense. So once I hit that 8/3, that's when the v starts being below the line. So you couldn't trust both answers. The graph is saying only the 8/3 is valid. And I hope that sticks with you. Probably won't, but I can hope, right? So it turns out with a v, don't trust it. Not until you look at a graph. And that's the moral of the story here. The moral of the story right now is nothing wrong with the algebra. It just shows you more answers than are possible to have. Sometimes, right? That's the ambiguity in it. Anywho, it's 3:07. I should have left 7 minutes ago. I'm done.